Hooray, we're starting chapter 10 and I am 1. We're going to talk about pairs of lines and angles. So, we want to know that two lines that do not intersect are either parallel or skew lines. So if you think of the room you're in, and that's how it says it, we're going to explore a classroom, or if we're still at home, then in your room. I want you just to look at a wall. And so parallel lines would be the 2 points where the corners meet. So you've got, the corner to your left and the corner to your right. Those are parallel. Skew would be if we had the top of a roof. So think of the top of your ceiling over here, okay, and then the corner over here. Those are skew lines. They are not parallel, but they are never going to meet because this one's going to go off this way and this one goes off this way. So that's what you need to understand. They are either skew or parallel, but they will never cross. And they give you some examples here, but I want you to look around your room and see. So this would be the ceiling and then the opposite corner. And those are good examples. So you can kind of look around and see things and identify them. Okay? All right. All right, so what we're going to do here is we're going to look at this figure and we're going to try to understand the classification and the reason for it. So the first one we're going to look for, and notice that each of these is lines. Okay, they have this symbol on top, which means they go on forever. So we're looking at AB and BC. So we can see that they intersect at point B, so the classification is that they are intersecting points. Okay, the next one we're going to look at is AD, that's this one, and BC, that's this one. So we can see that they're on the same plane, but they are parallel. So they are coplanar and they never intersect, but they are parallel, okay? So it'd be like the two corners of your ceiling that are across from each other, opposite corners, opposite sides. Okay, this next one's a little bit more confusing because of their definition. So we have EI, which they're calling line EI, and line IH, which would be this. So that makes all the difference. As soon as they have the lines going like that, we can say that they're coincident. Coincident means they're the same line, okay? So they cover the same points. They have more than one point in common. They do not meet at one point. They just share that point. And all of those points are collinear on the same line EH, okay? So that's key. If it had been EI and IH like that with the segment signs, then you would just say they intersect at a point, point I, but that would all they be. That would be all they have. But because it has the line symbol, that makes them coincident, okay? All right, the next ones, whoops, we went too fast. Skew. So we have BF, that's this one back here, and EH. So I want you to see that clearly. We already marked EH, so that one's like this. So you can see that they're not coplanar. This one's on this plane, this one's on this plane, okay, or you could say that one's on the back plane. And so they're not coplanar and they never intersect. Okay, think of the corner of one side of your room and the opposite line between the floor and the ceiling. Okay, they're never going to intersect and they are called skew. Okay, the next one is EF, so that's this one, and CG. So CG is like this. Again, I think those are skew as well, and that is because they are not coplanar and they never intersect. And the last ones we have are AB and GH. So those look like this. Now notice they are going in the same direction. They are not coplanar because they're on different planes. The AB is on this plane and CD is on this plane, but they are still parallel. So both line on a plane, and this is where they get tricky on you, they're going to create a plane. So they lay on this plane right here, okay? And that plane is ABG. So you just pick 3 points, A, B, G, and they lay on plane AG, so they are parallel, and will never intersect. Okay? So interesting to know they can take two lines and make them on the same plane like that. Okay? All right. Okay. This is the parallel postulate. If there is a line, we're talking about line L here, and a point not on the line, point P, then there is exactly one line that goes through that point that will be parallel to the given line. Okay? If there is a line and a point not on the line, point P, then there is exactly one line through the point that will be perpendicular to the given line. Okay, we can draw a lot of lines, but they will not be perpendicular. That's what they're trying to say. We can draw a lot of lines, infinite number of lines through there, but only one of them will be parallel. That's what they're trying to get through. Okay? All right, so identifying parallel and perpendicular lines. The given line markings show how the roads in a town are related to each other. So name a pair of parallel lines. So right here, I can see that this road and this road are parallel. Okay? And that would be MD and EF. Okay? Then I want to see what's perpendicular. So there's my symbol for perpendicular. And then it says, is FE parallel to AC? So here's FE, and here's AC, the red line, and they are definitely not, because they are going to intersect right about there. So there's all your answers if you want to stop and look through those. But remember, there's only, by the parallel postulate, there's only one line parallel to FE through line M. And so since that one also goes through line M, it can't also be parallel. So pay attention to their explanations. It's really helpful to understand things through a perspective of the postulates. Okay, so this is just another one, and it says, the given line markings show how the roads in a town are related to each other. Name a pair of parallel lines. Okay, and name a pair of perpendicular lines. And then is GN, that's this one right here, perpendicular to JL. Okay, so again, look at their explanations, and there's your answers for those, and here's your answer for this one. GN is not perpendicular to JL because JK is perpendicular to JL. So by the perpendicular postulate, there's exactly one line through G that is perpendicular to JL. So this is just another line that intersects with that. So make sure you pay attention to their explanations, because it's helpful to understand in terms of postulates and theorems when you start making proofs. Okay. A transversal is a line that intersects two or more coplanar lines at different points. So we don't have to worry about these being any relationship except what they're called. So if you look at your two lines, okay, you've got two lines and you've got this transversal. So the line T is always the transversal in this example here. So when you have two angles that are sitting on the lines in the same position on the same side of the transversal, those are called corresponding. Okay? So they are corresponding because they're both sitting on a line against the same side of the transversal. Okay, now we have alternate interior. So when they say interior, they mean between the two lines. And alternate means on opposite sides of the transversal. So alternate interior angles. Over here we have two angles are alternate exterior angles when they're on opposite sides of the transversal, but they're on the outside of the lines. So alternate exterior angles. Two angles are consecutive interior when they're next to each other. Consecutive means next to. So the numbers 1, 2, 3, and 4 are consecutive. And so 3 and 5 are consecutive, and they're both on the interior on the same side. So inside, consecutive on the same side. All right. So if you want to push pause, you're going to make a list of all of these things that are applying. And I want you just to look at this. You have to look at them kind of sideways, because here's the transversal and here's your two lines. Okay? So look at those and make a list, because there's a lot of each one, and see how you do. So go ahead and push pause. Okay, so let's look at corresponding. So corresponding would be 5 and 1, 6 and 2, 3 and 7, and 4 and 8. So those are all the corresponding angles, okay? Next, we're going to look at alternate interior. So we go to the inside and we go to the alternate sides, okay? Alternate interior. And so 2 and 7 and 4 and 5. The next one we're going to look at is alternate exterior. So we're going to look at exterior angles. So we're going to go 1 and 8 are on the opposite sides of the transversal outside the lines, and 3 and 6. Okay? And then the last one we're going to look at is the consecutive interior angles. And that would be 2 and 5 and 4 and 7. So hopefully you got those right and you understand what we're looking for. Okay. All right, so we're going to do a few of these on each page, but we're going to do 1 through 12 in the journal. So I want you to think of each segment in the diagram as part of a line. So all of these are lines, okay? And you're going to think about so we're looking at which line or plane contains point B and appear to fit the description. So everything has to fit point B. We're only talking about point B. So find a line skew to FG that contains point B. Okay, so think about point B, and that would be BC and BD. Okay, so they added a extra line there. Those are skew, so they're on this plane that is parallel to the plane that this one's on, and they're going in opposite directions, so they are neither parallel, but they are skew. Okay? All right. Okay, let's look for lines that are perpendicular to FG that go through line B. So that would be this one here. Okay? So BG. Okay, so now we're going to look at FG. What line is parallel to FG that contains line B? So that would be AB. Okay, and now we're going to look for a plane parallel. Look at the letters FGH. So FGH would be this plane here. So we're going to look at this as the parallel plane. And you could call it ABC, ABD, ADC, either one. Okay? So it's just important that you understand these relationships. Okay. So name a pair of parallel lines. So you see here that we've got one arrow. So we could say line WX and line YZ. And we also have another set of parallel lines. So we have two sets of parallel lines. And there you go. Okay, so now we're going to name a pair of perpendicular lines. So we've got right here, this line and this line. This is the only one. Now, here's a trick though, because since this line is parallel, since QR is parallel to UV, it is also perpendicular to ST. So you might not have caught that, but they did. Okay? Important. Then it says is WX, that's this line here, parallel to QR. So it isn't because it contains 9N, and so they are intersecting lines. It's just intersecting and not parallel. And then it says is ST perpendicular to NV. Okay, so ST is perpendicular to NV. So look at NV as part of UV. So yes, there's exactly one line through V perpendicular to ST, and NV is part of that line. Okay. All right. So now we're going to go back here. Now, I think this one is really, really confusing because it's hard to tell which one's the transversal. So there's tons of answers here, because if you think of these as your two lines, you have one set of answers. Then you could think of these two as your two lines and the other one's the transversal. Or you could think of these two as the two lines and the other one's the transversal, and they don't name them. So just think of as many as you can. So what I'm trying to say is, if I thought of these as my two lines, okay, then these would be corresponding. If I thought as these two as my two lines, these would be corresponding. So you can see there's all sorts of ways to look at this, but go ahead and give it a try and then see how many you came up with when you're done. So go ahead and push pause, because I'm just going to put the answers up and you're going to go, oh my goodness. Okay, so here are the possibilities because of the way they drew those lines. Okay, so if you want to turn the thing around and look at it from different angles, but I did it last night and I thought, wow, there is a lot here to think about. So that is the end of this slide, the end of 10.1. So obviously nothing will be this complicated on the homework, but it's good for you to think outside the box. Have a great day.